Hey, is this thing on? Are we recording? Can I get a tech person? Oh, for the love of ed tech. If you're tasked with managing hundreds or thousands of student Chromebooks, you'll want to check out our sponsor, Visor. Visor is a Chromebook and IT asset management software solution designed specifically for school districts. To find out how Visor can help your school manage Chromebooks and get 20% off, go to visor.cloud/loveedtech. That's VIZOR.cloud/loveedtech, or click the link in the show notes. Thanks, Visor. Joining us today is the Walnut Hills Robotics Team, the Nuts. I'm going to let everybody kind of introduce themselves. Rocky, you want to kick it off?
Sure, I'll kick it off. My name is Rocky Takalvi, and I am the coach of the Walnut Hills Robotics Team, and I have been doing that since 2012.
Hi, my name is Luke. This is my fourth year on the team, and I'm the programming lead.
I'm Daniel, and this is my second year on the team. I'm a junior.
I'm Abi. This is also my second year on the team, and I'm a sophomore.
I'm Tejas. This is my first year on the team, so basically I'm called like a rookie on the team, and I'm a sophomore.
I'm Hada. I'm a rookie on the team, and I'm a sophomore.
I'm Jack. This is my first year on the team, and I'm a junior.
Well, we're really excited to talk to you guys because, first of all, I want to know how many robotics teams, is this a normal thing for schools to have robotics teams?
There are a good number of schools with robotics teams. It's a pretty competitive scene. Here in Ohio, there are a lot of private teams and a lot of teams in public and private schools.
Cool. How did your team get started?
This has been and is still a student-led initiative, meaning that there were students at Walnut Hills High School who approached the principal and said, we don't have this program. This is a great program. They actually brought in an example of a robot in a PowerPoint presentation, showed the principal what it was all about, and he was like, this sounds like a great idea. This is something I'm going to get behind and something that we're going to do here at Walnut Hills High School. We are a part of FIRST, and that stands for Inspiration of Recognition of Science and Technology, and it was created by Dean Kamen, who is an inventor with many different patents, and his whole goal was to get students interested in the science and technology fields, and the robot component is the hook of it. The other part of this program involves these young students putting together what's called an engineering notebook and then talking to or actually going through a judging process at every competition that they go to.
Oh, that's cool. I like that it was a student initiative. How cool as your start. So yeah, somebody explained to me how this all works.
So basically every year there's a new challenge that comes out on this kickoff. So this year, basically the challenge revolved around putting these cones on different poles called junctions, and we get different amounts of points for different things like that. So maybe there's a high junction that we get 5 points for putting a cone on, and a medium that we only get 3 points for, or something like that. And we build our robot around that specific challenge. So from day one, we start brainstorming ideas in weighted objectives tables to basically decide which part of our robot would be best for each challenge. So you did the different mechanisms basically. And then from there, we go on to actually design those prototypes and eventually build our full robot. And so far, we've had 2 different league play competitions in Kentucky where we've been really successful and we haven't lost a game so far.
We do get to Worlds pretty often, and hopefully we can do that this year too.
When you get your challenge at the beginning of the season, do you guys work through the whole engineering and design process, or what does a practice look like?
So immediately we just watch the videos. They have videos that explain what the challenge is, and most of what we want to do comes from previous seasons. If there's something that looks like it could be picked up with a claw, we say, all right, we already know how to design a claw because we've done in previous years. And then we just start deciding which design to make, because there are a lot of different ways to skin a cat. But yeah, we figure out what to do, we prototype, and we build, and then we have a robot.
So then do you battle? I mean, like, what?
Oh, sorry. Yeah.
Just like, I don't know.
So it can be pretty much everything but battling. So it's usually moving one thing from one place to another in order to score. You have to sometimes move the robot to a certain place, sometimes read something, sometimes just put a block from one place into another.
So I guess just to elaborate on that, the way a match typically works is there's two alliances. There's a red alliance and a blue alliance. There's typically there's two teams on each alliance per match, so 4 robots on the field at a time, which in a 12-foot by 12-foot space, it's not very easy to move around. So you have to have a lot of game strategy and a lot of communication with your partner. And then you're working with your alliance to score as many points as possible and hopefully beat out the other alliance to win the match. And the way a match is structured is, so it's a 2-minute, 30-second period. The first 30 seconds is all pre-programmed. It's called autonomous. So all the things that the robot are doing are all pre-programmed pieces that our programmers have put together, and hopefully there's specific tasks inside of that autonomous period which we try to accomplish. And then after those 30 seconds, the next 2 minutes are all driver controlled. So we have these controllers, almost like your Xbox controllers or your PS4 controllers that we use to drive around our robot and score points manually.
To paint a more solid picture, we should probably explain what we're doing this season. The idea of it is you put cones onto sticks. You just grab a cone, you lift it up, and you put it on a stick, or you put it on somewhere on the floor. But basically, there are 4 robots on the field trying to put as many cones on sticks as possible. There are other aspects, like you have to park your robot in places before time runs out. Or
So you have time challenges to, like, is everything timed?
Yeah.
Okay. So tell me why you decided to join the robotics team.
So before I joined the robotics team, which participates in First Tech Challenge, I was part of something called FLL, First Lego League. And it's basically this, but on a much, much smaller level, where we are using Legos and much non-custom parts to build our robot. So we're ordering these kinds of kits and just putting it together, and I guess having fun with Legos. But I knew I always wanted to do something bigger than that, and this robotics team gave me that opportunity to do that. So I was really excited when I was able to join.
I got my start in First Lego League, and when I came to Walnut Hills, I really wanted to join the robotics team right away. But I found out that the team is limited to 9th through 12th grade, and I came in 7th grade. So I spent 2 years coming to practices and competitions, trying to help out and learn what I could and meet the team, so that when I ultimately applied for 9th grade, I was prepared to start contributing to the team immediately and working on the projects I wanted to work on.
I never did First Lego League, but every year this team hosts an open house, and anyone from the school can just come and see what's going on and then apply if they want to. So that's what I did, because who doesn't like robots?
Yeah.
The way I found out was kind of pretty similar to Avi. We were actually both on the same First Lego League team back when we were in elementary and middle school. And then we both ended up going to Walnut. And when we heard that there was a First Tech Challenge team right here that was really successful, we were both really interested. And actually, I applied in 9th grade and wasn't able to make the team, but then I worked really hard over the next year and visited some practices and actually applied again as a sophomore and was able to make the team.
I found out about the team through the annual club fair hosted at my school and signed up. I actually applied last year, but didn't make the team, so I applied again this year, and after my interview, I made the team and have really enjoyed working with it ever since.
That's awesome. All right.
I was on an FL team in New York, and when I moved here, I knew I wanted to join the FTC team because it gives that more hands-on engineering experience.
And let me tell you, Kara, if I can, how these kids go about being a member of the team.
That's what I was going to ask.
All right.
Yeah, every April we hold an open house so that any student at school can come down and see what the program is all about, how we run it, what we do, and then they have to fill out an application. And through that application process, they are invited to interviews. Interviews are done by former team members, coaches of the team. And then based upon those interviews, what we do is we look at this team as a jigsaw puzzle. And we have returning pieces coming back the next year. And what we do is we try to find people who we think are going to mesh well with what we have returning so that we can have a cohesive team. Once they've gone through the interview process, they're invited onto the team. They then have to go, they agree to go through a summer curriculum that we've put together for them. It is a 6-week program where 1 week they get a unit, a chapter, if you will, of the curriculum. The next week they get questions they have to answer. And as they go through those 6 weeks, those answers depend upon really whether or not they're going to be on the team. If they give us really poor work that's not going to be conducive to being on the team, they won't make the team, even though they've been invited to be on the team. And the goal of that summer curriculum is to get the students who are new as prepared as possible. So when the season does start in mid-August, September, that they are able to jump right in and help out, because there is a very steep learning curve to this program. And what we found early on was when we didn't have a summer curriculum, that there were students who came in and they were just totally lost. And we wanted to try to avoid that. So we put that together for them. So it's a process of, seeing what's going on, applying, interviewing, which are things they're going to have to do when they get ready to go to college, things they're going to have to do when they go get a job in the real work world. So not only are we asking them to be on this team, we are trying to prepare them for everything that's going to come down the road in their life as well.
Yeah, which I think is a great approach, whether you guys know it or not. Yeah, because I'm curious, what do each of you kind of plan to do in the future?
I'm a senior, and so far I've applied to a bunch of colleges for computer engineering.
Okay.
And that and computer science are the two fields I see myself going into the future with, which has a lot to do with my time on the team.
Mm-hmm.
Luke's being very modest. Luke, explain what award you guys got at the World Championships last year.
We were nominated as one of 7 finalists for the Control Award, which is the programming award that was offered at the World Championships.
Oh, wow. So, okay, what all do you have to do to these robots?
We use a program called SoundShape to CAD all our stuff after we prototype. I mentioned the weighted objective tables. Mm-hmm. So we brainstormed a bunch of ideas, and then we need to decide which one to use. So we throw it all into a decision matrix, decide which one we want to use in a little more of a objective way, but with our own preferred weights, I guess. So then we CAD it, and we CAD each of the parts, and we can see what we want to have. Then we have to build it. So the place where we practice is a really good makerspace that lets us use their space and their tools and gives us training all for free.
Awesome. That is awesome.
Which is very generous.
Mm-hmm.
They've been doing that for a long time, and they have all sorts of machines like plasma cutters, laser cutters, saws. We have some 3D printers ourselves, and we use that all to put what we have on CAD into the real world and assemble it, wire it, and then programming it.
Okay, so you guys are building from scratch.
They are building
from scratch. Okay.
They get the ability to take their theoretical ideas, CAD them, and then actually cut them out, if you will, machine them out, if you will, and apply that in a real world setting.
Which is cool, because I guess in my head, I envisioned pieces of it being kind of like almost given to you to like say, take this and, make it do stuff.
We do purchase commercial off-the-shelf parts, which is another part that kind of prepares us for engineering. because we go through product catalogs and find which parts have the specs that we need and the dimensions that would fit into our designs best.
Oh my gosh.
Our robot wouldn't work very well if we tried to make our own motors.
Teachers, you can now earn contact hours toward grad credit for listening to the podcast.
Visit fortheloveofedtech.org for more information.
What do each of you think that this being involved in this team has given you, like personally, whether it's like extra friends or whether it's, you know, just the real world skills of it, or like what has been the most positive thing for you that's come from being involved in the robotics team?
You learn, of course, a lot about teamwork, how to work with others, and about whatever you're doing on the team, like CAD or programming or just assembling stuff. It holds a lot of value in just the confidence I've gotten from being on this team, because part of a competition is judging. You have to stand in front of judges, explain your robot, explain your season, and basically not freeze. We practice it a lot, but over time you get comfortable with it and you learn how to get comfortable in basically any situation where you're trying to talk to someone, which is important.
Yeah.
So for me personally, I did 2 solo sports, tennis and cross country. So I never really, while I've gained a lot of things from both of those sports, I never really had that teamwork aspect that Daniel was mentioning. So this kind of opportunity presents that for me. So it's really fun to just be able to hang out with a group of people who have the same interests as you, and you can combine your skills to make an amazing product. And also, you can make the best product possible, but if you're not able to explain it and reason it out as to what you did, then it's not really, you need to learn those skills as well. So the entire public speaking part and presentations aspect is also really important. And I think I've gained a lot of valuable lessons from that as well.
That's great.
For me personally, just so far, I've only been on the team for a couple months, so I haven't necessarily had the same experience with judging that I'm gonna have to find out later this year.
Yeah.
But I think the space and the really ability to go through the engineering design process at a local makerspace is really been instrumental to me in the way I see where I want to go in the future in college or even a job. I think because even at the start of the year, even in the summer, we wood and metal shop training at the manufactory where we practice. And from there on, it's been really opened up my eyes to the possibilities in engineering.
I think that this team has just helped me realize the value of others' perspectives and their own experiences, and how that makes them a valuable addition to whatever project I'm working on. I've worked on a few teams through school and through clubs and things like that in the past, even on projects similar to this, but never have I been on one as well meshed and well balanced as this team. And this kind of taught me to just use others' perspectives and their own experience and not just try to go it alone.
Yeah, no, that's great.
Previous to being on this team, I didn't really have the ability to talk to real engineers and talk to like-minded people, but being on this team has given me access to all the tools I would be using as an engineer, and I'm able to talk to people who are also interested in it. So it's really refreshing to gain more perspectives about engineering and more knowledge about it.
I love that.
I've mostly developed my programming from robotics on my own and balancing what I need to know and what I want to learn. Through robotics, I've especially learned a lot about machining and, like Huda said, talking to like-minded people and engineers. Specifically at the manufacturer or makerspace, there are several engineers who are regulars there or who work there, who are always ready to help us out, lend us tools, and show us how to use, for example, a manual mill to create a part.
Yeah, that's really cool. I'm kind of jealous of you guys with that.
And I think the overriding thing that these guys also learn is the fact that if you're a programmer, if you understand the build side of it, it's much easier to do the programming because you know where the build's coming from. And if you're a builder, you understand what the programmers need, so they learn how to work together and mesh really well.
Which is really valuable. I mean, even in other fields too, because we talk about this with like the guys in IT who do like the wires and hardware-y type stuff. If they don't understand the teaching side of things, and vice versa, the teachers don't understand the IT, it makes for, you know, it can.
There. Yeah.
Yes. Yeah, it makes for difficult situations when you're coming from two different sides. Hoda, I was going to ask you, I hate to single you out, but I wanted to know what it's like to be are you the only girl on the team, or is...
Yeah.
Okay. What's it like to be the only girl on the team?
I mean, I would love for there to be more girls on the team next year, but I work pretty well with the team and we're all like-minded, so I don't feel too much of a difference. I still work pretty much the same as any other team member.
Yeah,
sure.
I do think there's a little bit of a divide when it comes to engineering, especially at in high school. I wish that there was more people who would try to get into it, more women who try to get into it.
Yeah, I hope so too, because I think there's a statistic where if girls aren't exposed to computer science or engineering by the age of 9 or 10, it's something kind of wild, that the likelihood of them going on to do a job within that realm is low. We have that conversation too, because we like initiatives like Girls Who Code and things that put that focus on the younger, get them while they're young.
Yeah.
Oh, that's awesome.
Rocky, tell us how you ended up coaching.
I told you that it was a student-led initiative.
Yeah.
What I didn't tell you was the student was my son.
Oh, there you go. That's how you get sucked in.
Yeah, he went into the principal, and really he had done this in junior high, where he went to junior high. So I shouldn't say junior high, because Walnut starts at 7th grade. He did this as a 5th and 6th grader where he went to school. And then when he went to Walnut, they didn't have it. And he actually looked at the principal during the interview and said, "Do you have robotics at your school? Because if you don't, I don't know if I can come to your school." And the principal, yeah. He's a little different.
I love it.
And the principal,
I love it.
The principal knelt down, looked at him eye to eye, and said, "Well, if you come to my school and you explain what it's all about, we'll look at getting it." And he goes, "Well, that sounds fair. I'll come to your school." So when that all happened, this is a, if you will, a volunteer position. When he went in and did the little presentation to the principal, the principal turns around and goes, "Well, we need someone to coach it. We need someone to run it." And when your son turns and looks at you and, okay, I'm in. Yeah. And I'd watched him do it. My wife is the other coach, is the assistant coach.
Oh, nice.
Yes. So we both got involved. We both understood it. And the really neat thing is neither one of us, my wife or I, know how to program, know how to CAD, know how to do any of those things. But that's not up to us. We're not on the team. We mentor them. We're coaches. These kids do all the work. They have to learn it. They have to do it, because they're the ones who, when they get out in the real world, are going to be relied upon to get it done. Yeah. And that's why it's important in judging, because they can go in judging and they can fully explain the exact process they did because they did it.
Right.
I mean, there are people who can assist and help them, but they're the ones doing the work. They're the ones doing the research. They're the ones failing, learning from that failure, figuring out a better way to do it, failing again, figuring another better way to do it, and continue to iterate and move the process forward. And that steads them really, really well when they get down the road, because they know that they've learned how to do things. They've learned how to fail, figure out what the failure was, and how to move it forward.
Which we love, because we talk about it all the time, about the failure and how it's like a great learning.
You have to learn that skill, because it's going to happen, whether it's in your personal life, professional life. Things are going to happen, and you just have to figure out how to move forward.
Yep.
I'm so glad you talked about that too, about you not necessarily being an expert, because I think there's so many parents and educators who are hesitant to get involved with these sorts of clubs and activities because they're not the expert, especially teachers. We want to be the expert before we teach something, and you really don't need to.
No, that's the best way for these guys to learn isn't somebody to tell them how to do something.
Right.
It's them going out, figuring out how to learn how to do it, and then actually putting it together and creating it.
Yeah.
I say it's the same with students too, because a lot of people just say, I don't know how to program or I've never built a robot, but
Yeah.
You learn more on this team than at least I have ever learned outside of it.
That's awesome.
It's great.
I didn't even coming into this team, I didn't even know what CAD was. So none of us really, I don't think I can speak for all of us. None of us were experts, and none of us still are experts because there's still a ton of room to grow. But you can't be an expert because then what's the point of being on the team?
And the nice thing about this team is that the new team members are learning from the ones who are there. And they keep building every time there's a new group that come in. They've got all the knowledge that's been passed down since 2012, since the original team started. So it's very hands-on. It's very, again, as I've said before, it's student-driven. These young people do all the work.
Yeah.
When these kids have finished this program, we ask them for one simple thing to do, and that is, at some point in time in your life, when you're able to do it, give back. There's a lot of people who are giving a lot of things to these guys so they can do what they're doing now, and somewhere down the road, we would really like to see them pay that back and give back in some way, some shape, however they can do it that fits their world.
Yeah, that's awesome.
There is one aspect that we didn't really cover, which was the engineering notebook and engineering portfolio. So going along with like the technical part, there's also the part where you have to discuss your journey as to how you built that robot and the daily practices of how you went along through your process to get to the final product. So the engineering notebook is basically a notebook where after each practice, we're going to record the notes from that day, what we did, what we want to reflect on, what needs to get done. And that way, when we go to competitions, the judges will see that entire process and then basically judge us on that, how that entire thing went. So it's basically just to help us keep track of what we're doing as well as help the judges figure out what we did.
How long is a typical practice?
On Friday, we get to the manufactory maybe around 4 and then stay as long as we need to, which changes. So I would say around maybe 8 on average.
Wow. Oh my gosh.
I'm just really impressed with the time commitment that you're making to this.
And that's why they go through the interview process, because we know and understand what's going to be required. And if they're not really up to that, then there's someone that they're not going to mesh well with the team, and it's just not going to happen.
We do have like a lot of time commitment in our robot. We're an old team and want to do better every year, but not all teams put in exactly the immense amount of hours. Like some teams are more casual.
It all depends upon the goals of the team. And we sit down at the beginning of the year and say, what are the goals? If the goal is just to have fun, go have fun. If the goal is to make it to world championships, well, then there's a level of dedication, a level of input that they're going to have to do in order to make it to that level. Because in Ohio, specifically within the 275 loop, there were 3 teams last year from Ohio that made it to Worlds. They were all from within the 275 loop.
Oh, wow.
Yeah, so it's a very competitive situation, and if you want to do well, you have to be willing to put the time and the effort and the energy in.
Right.
Yeah. Which bravo to all of you. Yeah.
When you go to a competition, it's a great experience because everyone's really friendly and everyone seems to be having fun, which is nice because it's not something we experienced as much last year due to COVID.
Oh, yeah.
I can see that. So if you're on the robotics team, is this pretty much the only extracurricular you're doing, or are you able to do other things as well?
The number one priority is your schoolwork. And if their schoolwork suffers, they won't be allowed to come to practice. So they have to stay up on that first. Then this comes afterwards. And that's made very clear to not only the students, but the parents as well.
The first year when I applied, I was doing like multiple different sports like soccer and swimming, and really I just didn't have a good idea of like actually how much time commitment there would be. So like it was kind of like a rude awakening at the interview when I was like, oh, wow, that's a lot more than I expected. But then like over the next year, I was really like learn more about what I like really liked and what I didn't have as much time for. And so I really like knew the actual time commitment that it would require when I applied the next year, which I think helped me.
That's why I was just thinking when I was in high school, I don't think I could have done what you're doing and a sport or anything like that. My soccer coach would not have had it, but what you're doing sounds way more interesting. I wish we would have had something like this. We had nothing.
Well, the nice thing about this program is the motto of FIRST is that everyone can go pro in their chosen sport. And this is their chosen sport.
Yeah.
That's awesome.
So exciting.
Yeah.
It is. I'm just like very jazzed. We're just getting started with Lego League in our house, and I'm just so excited to hear how much you all are enjoying it and everything. I got sucked into coaching, so we'll see how that.
Well, if you need any mentors, there are 2 here who did that when they were younger.
Yeah. Well, I may reach out to you. I've got a first grader, 2 second graders, a third grader, and a fourth grader. It's going to be a wild ride.
Good luck.
Thank you.
Been there, done that.
Well, thank you so much for talking to us.
No, Kara, thank you.
Yeah, this is great.
Thank you for joining us. We hope you enjoyed our discussion today. If you like our podcast, please don't forget to subscribe to get notified when new episodes are released. For more information about our podcast and to access links and resources referenced in this episode, check us out at fortheloveofedtech.org.